Good morning, dear cadets. The long form of periodic table, also called modern periodic table, is based on modern periodic law, which states that properties of elements are the periodic functions of their atomic numbers. The repetition of the similar properties of the elements placed in a group and separated by certain definite gaps of atomic numbers is known as periodicity. Worry is not up to uranium. We have to think giving names for the elements whose atomic number is more than 100. The elements having atomic numbers greater than 100 have been discovered during artificial transmutation of elements. Transmutation of elements means conversion of one chemical element into another by inducing method or by neutron bombardment method or some other method that we learn in radiochemistry or nuclear chemistry. These elements are highly unstable because of proton-neutron ratio of their nuclei. Once again, we learn in nuclear chemistry and are obtained only in minute quantities. Whenever we require, there and then we prepare and study their properties. This has led to several complications in deciding the claims of more than one scientist for the discovery and names assigned by them for a new element discovered. To give an example for this point, the element having atomic number 104 was discovered by both America as well as Soviet scientists. The American scientist named it Rutherfordium, whereas Soviet scientist named it Kurchatovium. In order to avoid complications and to find amicable solutions, IUPAC, International Union of Pure and Applied Chemistry, in 1994 appointed CNIC, Commission on Nomenclature of Inorganic Chemistry, and has made an official recommendation that a newly discovered element to be named according to the rules of IUPAC till its discovery is confirmed and approved by it, which we are going to learn today. So let's start today's session on nomenclature or naming of elements whose atomic number is more than 100. Usually, when a new element is discovered, the discoverer suggests name of IUPAC guidelines which will be approved after a public opinion. In the meantime, the new element will be called by a temporary name coined using the IUPAC rules until the IUPAC recognizes the new name. The name was derived directly from the atomic number of the new element using the following numerical roots. So these are the roots for the numericals. In the atomic number more than 100, for which digit, which root is there, that IUPAC has made a table. So this is the table made by the IUPAC. For 0, nil, for 1, un, for 2, bi, for 3, tri, for 4, quad, for 5, pent, for 6, hex, for 7, sept, for 8, oct, for 9, in, and accordingly their symbols or the abbreviations are: for 0 it is nil, so first is taken n. For 1, un, u is taken. Similarly, for 2, b, 3, t, 4, q, 5, p, 6, h, 7, s, 8, o, 9, e. The numerical roots corresponding to the atomic number are put together and IUM is added as a suffix. That means after the digit, according to the digit root is given, at the end IUM is added so that name is completed. The final n of ENN is omitted when it is written before nil, because at the end of ENN, n is there. In the beginning of the nil, n is there. So out of 2n, 1n is taken. Similarly, the final I of buy and try is omitted when it is written before IUM. Here also same rule, because buy and try ends with I. So IUM begins with the I. So both are I only. One I is taken. For example, buy plus IUM, buy M. One I is omitted. Try plus IUM, try M. So one I is omitted or removed. The following, the symbol of the new element is derived from the first letter of the numerical roots. The following table illustrates these facts. This is the table. For example, 101, for 1, un, for 0, nil, again for 1, un, nil, un, and at the end IUM. What is the name here? Name is Anil Unniyam. Accordingly, symbol is made from the un u is taken, from the nil n is taken, and from the one more un u is taken. So UNU is the symbol. This name and symbol are temporary. The correct name is Mendelevium, because this is his name is kept for the discovery. So these are the final name. But before that, if you want to name 100 or 200 or 3000, you follow strictly IUPAC nomenclature rules and regulations. Now for 1 or 2, un, nil, by, IUM, unil by m. So UNB, it is called nobelium, NO, permanent symbol, temporary symbol. Earlier, this was not discovered. Okay, so we have kept this name when this was discovered by certain scientists according to the origin name of the place or name of the scientist. At the end, permanent name is made as NO. Keep in mind nobelium, the word. Okay, like that. So temporary we make the name. Once it is discovered, then a permanent name is given according to the scientist name or according to the place from where it is originated. One more example here. For 103, un, nil, trium. So symbol UNT. This is called Lawrencium, LR, already there at the bottom of the modern periodic table. 104, unyl quadrium, UNQ. It is called Rutherfordium, RF. For 105, Anil Pentium, UNP, Dubnium is the today's name. For 106, Anil Hexium, UNH. So this is popularly called as what? Seborgium, SZ. For 107, it is Anil Septium, UNS is the temporary symbol, and it was named afterwards after the confirmation as Borium, BH is the today's symbol. For 108, it is called Unnil Octium, Unnil Octium, Hassium, HS. See, now 109, Unnil Innium, UNE. Okay, this is the today's name. Now for 110, Unnilium, Nilium N. So UUN is the temporary symbol, but afterwards this is the present name of the this 110 and its symbol is DS. In the same way, for 111 it is Unnium, UUU, named after the scientist who discovered the X-rays Ronzium, RZ afterwards. Now for 112, Unbium, UUB. Okay, so Copernicum. Now for 113, it is Untrium, UUT, Nihonium, NH. For 114, Unquadium. So you can continue up to 110, 300, 400, up to lakh you continue. This is what strictly according to the IUPAC rule. Now we'll go to another small topic of the chapter, uh, electronic configuration, because modern periodic table depends on the atomic number, and using atomic number we write the electronic configuration, and electronic configuration decides the properties. Therefore modern periodic table depends on what? Electronic configuration. So let us learn electronic configuration separately in the group and in the period. Okay. The electronic configuration of an atom is the numerical representation of the arrangement of electrons distributed in the orbitals of the atom. So using the numbers, using the symbols, we write the electronic arrangement, that is called as the electronic configuration. This determines the position of an element in the periodic table and in turn its chemical behavior. By looking to the electronic configuration, we can tell exactly where the element belongs on the modern periodic table, in which group and in which period, and also we can come to know its chemical behavior. That's why electronic configuration is very important. It explains how the atoms are held together by the chemical bonds and the peculiar trends which are observed in the rows and columns of the periodic table. That means how the elements behave in a period and in a group, that can be studied by understanding the electronic configuration. So in tomorrow's discussion, what we learn? We learn separately electronic configuration in periods, then electronic configuration in the groups, so that both becomes clear. Then we'll go to the some other small topic. Thank you, my dear students.